Okay, boys and girls, today's lesson is going to switch from perimeter and area, and now we're going to focus on volume. So I'm going to start off by showing you some of the pages that we have in the textbook and talking a bit about what it means when we say volume. So here we have, here's a box with a pair of shoes in it, and it asks, how could you find out how much space there is inside this box? And the answer is you could fill it up with different things. You could see how much the box holds. Here we could say that the volume of this box, how much it holds, is 2 shoes. That's what it can contain. If you look at the, we won't do this example here. If you look at, so the amount of space inside an object is the amount of space inside an object is a measure of the volume of the object, okay? How much can go inside it. And you can find the volume of a box by filling it with identical items and then counting them. So in this picture here, we have a box that holds 144 sticks of chalk. We could say that it has a volume of about 144. Now, the reason that we use the word about is because it doesn't hold exactly that much, because there's actually spaces in between the pieces of chalk. So we use about to describe the volume because the items don't fill all the space. Below that, we can say that this box down here holds 80 sugar cubes. Now, we're not going to use the word about here because 80 sugar cubes will fill the box without leaving any spaces. So when we measure volume, it's useful to measure volume with something that doesn't leave spaces, like sugar cubes. They stack together nicely. If we look at the volume of this bag, the volume of this bag is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It would be 12 slices of bread. That's how much that bag can hold. If we look at the volume of this box here, the volume would be 24 crayons. That's how much the box can hold. If we looked at the volume of this box of donuts, it holds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The volume is 12 donuts. Okay. So we can talk about volume being how much it holds. We don't measure volume in slices of bread or in crayons or in donuts, though. We use something else to measure volume. And we'll talk about that in this next lesson, because we measure volume in something called cubic centimeters. Now, if you think of a centimeter as being a line that is 1 centimeter long, that's the length. Okay? And we measure perimeter in length. We measure the length of the sides of a square. However, if we take the length and add to it the width and so on, we get this inside. We have what's called 1 centimeter squared, and that now we have the area. And the area is the length multiplied by the width. To find volume, we have to take that and turn it into a cube. We have to turn it into something that's 3 dimensions. We now have length times, so there's a length, times the width. Now we have to times it by the height. So this is 3 dimensions, length times width times height. So now we have centimeters cubed. Cubed being that we could make a cube out of it because we've got 3 dimensions, length, width, and height. This is centimeters squared because we have 2 dimensions. We have length and width. And this line is just centimeters. It's just 1 dimension. So we have 1D, 2D, and 3D. Or centimeters, centimeters squared, centimeters cubed. This is what we use for measuring volume, is cubic centimeters. We can't do that. So now it's a good opportunity to go and check out the Math 5 live video on volume. It's a really good video to do. So it will only work if you can use Flash on your computer. It might not work on a tablet. It will work on a Chromebook or a computer. Check that out. So how many cubes will it take to fill this? Let's see if this works for us here. And okay, simulation. Okay. Okay, that's not working. No good there. Okay, I'll get rid of that and we'll go back into this. Okay. So the volume of an object is a measure of the space it takes up. And the length, okay, so we talked about the length of each of these centimeter cubes is 1 centimeter. A centimeter cube has a volume of 1 cubic centimeter. So this here equals 1 centimeter cubed. And we can use centimeter cubes to measure volume. This rectangular prism here, it has 4 rows of 5 cubes. So here's 1 row. Oh, they've got that wrong, the wrong way around. Okay. It's got 1 row of 5, 2 rows of 5, 3 rows of 5, 4 rows of 5. So it has a volume of 20 cubic centimeters. This object here has 8 cubes in the bottom layer. Now you can't see them all, but there are 8. There's 4 there, there's 4 in that row, and there's 4 in the row behind. That means 8. Then you have 3 on top. So 8 plus 3 is 11. So it's got a volume of 11 cubic centimeters. Now, in these questions we have here, we have to find the volume of each prism. Now you can count them and think, well, there was 1, 2, 3 here, and the 3 behind, and so on. There's also another way of doing it. You can use the formula, which is volume is length multiplied by width multiplied by height. So here we have a length of 3, we have a width of 2, and we have a height of 2. So 3 times 2 times 2. Length times width times height. 3 times 2 is 6. 6 times 2 is 12. So the volume of this prism here is 12 centimeters cubed. This one has a length of 3, a width of 2, and a height of 3. So it's 3 length times 2 width times 3 height. So 3 times 2 is 6 times 3. 6 times 3 equals 18 centimeters cubed. This one here has a length of 2, a width of 2, and a height of 2. So it's length times width times height. 2 times 2 is 4 times 2 is 8 centimeters cubed. This one here has a length of 4, has a width of 3, and has a height of 4. So 4 times 3 times 4. 4 times 3 is 12. 12 times 4, you have to know that one, is 48 centimeters cubed. Length of 5, width of 3, height of 2. To figure out how many are in here altogether, 5 times 3 times 2, length times width times height will tell us how many cubes are in this altogether. 5 times 3 is 15 times 2. 15 times 2 is 30 centimeters cubed. Not squared, it's cubed. This has got a length of 4, a width of 1, and a height of 4. 4 times 1 times 4. 4 times 1 is 4. Times 4. 4 times 4 is 16 centimeters cubed in that prism there. These ones, again, you'd have to find out how much is in each layer and add them all up. So this is 1, 2, 3, 4, 5. 5 times 1, 2, 3, 4, 5. So there's 25. plus 9 plus 1. So this has got a volume of 35 centimeters cubed. This one has a bottom layer, 1, 2, 3, 1, 2, 3, 4. So a bottom layer of 12. 1, 2, 3, 1, 2. So this has got 6, and this has got 6. I'll just add them all together. So it's basically 12 plus 12. So that one has a volume of 24 cubic centimeters. This one has got a base of 12, because I'm thinking 4 times 3 is 12. And then 2 times 3 is 6. 2 times 3 is 6. Add them up all together. That's also got a volume of 24 cubic centimeters. 2 times 2, so it's 4, 4, and 2. So that's got a volume of 10 cubic centimeters. All right. So again, same idea that this cube has a volume of 1 cubic centimeter. So 1 cubic centimeter wide, 1 cubic centimeter high, 1 cubic centimeter wide, 1 cubic centimeter, 1 cubic centimeter, 1 centimeter long, 1 centimeter wide, 1 centimeter high, that's right. So you'd find the volume of all these. So you're now going to work on some questions that are look like this. Oops. This question page here. Now here, this is the sheet that I'm going to be giving you shortly. And won't show you the answers. But what you have to do is, okay, look at the, here's a demonstration here. How many cubes are in the bottom layer? Well, I'm not going to look at the bottom, I'll actually look at the top. There are 1, 2, 3, 4, 5, 6, 7, 8. The top there is 8 by 1, 2, 3, 4. 8 by 4. 8 times 4 is 32. So there's 32 cubes in the top in one layer. Now, how many layers are there? Well, there's 1, 2, 3, 4. There's 5 layers. Okay, number of layers is 5. So then 32 times 5, you may have to use a calculator, 160 cubic centimeters. So following those steps, work on those pages for the challenge on finding out the volume of different prisms.